G'day. In this episode I'm going to talk about this car battery monitor kit that I bought from Jaycar Electronics more than 20 years ago, I reckon. It's a simple little kit based on the LM3914N LED driver chip or display driver. The circuit itself was designed way back in 1987 by Electronics Australia, and now defunct Electronics magazine in Australia. In fact, Jaycar Electronics is also defunct now. So we're going to go ahead and make this kit, which consists of this simple and quite small and compact PCB, single-sided, nicely made, and only a handful of components, which I've sort of mustered together. They've been sitting around for, as I said, 20 years, so there's hopefully some of these pins on the components aren't too corroded and they'll solder up okay. Now, despite the age of this kit, it proved to be very popular, and in fact the latest catalogue from Jaycar, which is an electronic component and kit supplier in Australia with many stores throughout Australia. They still have this kit available, and there you can see it. Car battery monitor, refer Electronics Australia, May 1987. The kit originally came with rectangular LEDs, but Jaycar has substituted ordinary 5mm round LEDs for the circuit, and I imagine the circuit board is slightly different to the one that I have here from Jaycar Electronics. So that's I guess a testament to the popularity of this kit, and in fact the popularity of the LM3914 display driver. So once again we arm ourselves with a data sheet. This is a copy of the original data sheet from National Semiconductor. There isn't a different version now under the Texas Instrument brand, because they ended up buying out National Semiconductor at some stage. Once again, the data sheet shows all the specifications and electrical characteristics. Some nice graphs, performance characteristics and so forth. Functional description. And then it provides quite a lot of typical applications and different circuit arrangements, and how you can use this chip, which is quite adaptable for many different applications. So there's plenty in the data sheet for you to examine. And also the Forrest Mims engineer's notebook, which is a fairly old book, but it is still relevant for many of these older chipsets and integrated circuits. They also have a whole heap of different applications and circuits for you to try out. Forrest Mim actually describes this chip as one of the most important chips in this notebook. So that's saying quite a lot, really, about the popularity of this particular chip. So I've got the original instructions here and the original how to construct it, component layout, etc., parts list, and we have the circuit diagram here. So what we're going to do is go ahead and make it. I'll just zoom in there and have a look at that circuit diagram. What we've got here, we're monitoring the battery voltage, and we have the battery voltage coming in here through a resistor and a capacitor to decouple it, and there's a 16 volt Zener to provide some over voltage protection, and then there's a little voltage divider network to reduce the voltage down to a usable level into the IC. The resistor network here is used to determine the range and the LED current, and we also have a separate ignition supply here, the idea being this is meant to go into an automobile, so you'd take your main LED supply off the ignition, so it's only on when the ignition switch is on, and also because you want to measure directly from the battery terminal, more or less, to get an accurate readout of the battery itself rather than any voltage drop up to the ignition, the fuse box and so forth. So that is their version of the circuit. So we'll go ahead and make this up as per the instructions and see if we can get it to work. Okay, as expected, I had some problems with the corrosion on the component leads, making it a little bit more difficult to solder, but eventually I think they're mostly good now. So what we'll do is go ahead and install the LM3914. The kit came with an IC socket, so that's always good. We can reuse the chip later on if we want to use it for another project or something. Alright, so we can test it out now. What we're going to do is just I made up this little jumper here to bridge the ignition pin and the battery pin. Careful not to let them short out. And I've connected it to my little dual tracking power supply, which incidentally is another one of the little kits that I've made over the years, and it's probably proved to be one of the most useful. In this case it's a silicon chip magazine design, and the kit was made by Electronics. Okay, so what we do is we're going to follow the testing procedure in the instruction document. And we're going to wind it up to 14.4 volts. Like so. And we're adjusting the little potentiometer so that the LED only just lights up. And then we're going to wind the voltage back down to about 11 volts, and the first yellow LED should light up at about 11 according to the test procedure. It's actually at lighting up at 12. I'm not sure if you can you see that? Let's just turn those lights off again, and so we've got some. Alright, so we've got our first LED, the yellow one, on at about 11.5, and then as we slowly increase the voltage up to well, that's about 14.6 now. I'll just drop that back down. Get that down to 14.4 again. Okay. So the first yellow LED is lighting up at around about 11.4 volts, which is okay, and then we're winding up the voltage up to about 14.4. The red LED comes on. So there you go, there is your car battery monitor. Seemed to work first time, which is good. So my solder joints weren't too bad after all. So what we might do now is we can, I've got a couple more of these chips lying around. What I might do is get the breadboard out and just experiment around with a couple of different circuits from the previous documentation that I've showed you, the data sheet and Forrest Mims engineer's notebook, and yeah, have a little bit more of a play around with them. Okay. Okay, what I've done here is put together one of the circuits from the original data sheet for the LM3914. This is the bar display with alarm flasher circuit. And you would have noticed when I put the kit together, it was in a mode where only one LED lit at a time, and that's called the dot display mode, and that's there's a mode pin on the IC. If you leave it unconnected, it is in a dot display mode. But if you tie it to the supply volts, the display becomes a bar display, and what that means is each LED lights up and stays on as the signal voltage is increased. We've got a simple capacitor and resistor here to create a little timing circuit so that when the last LED lights up, all the LEDs will flash at a rate determined by that RC network. So let's power it up and see if it works. As you can see, it started to flash straight away because my signal voltage is a floating voltage. And so let's just get some small voltage on there. Alright, I've got a little voltage generator here. We'll slowly start winding up the volts. That's 0.2 volts. The first LED is lit. Right, that's 9 LEDs lit, 1.2 volts. And it should theoretically start flashing, but I think we might have a little loose connection on that capacitor or something like that. Okay, I jiggled around with it and fiddled about and remade a few connections, and now it should be working. So now if I slowly increase the voltage source, you'll see each light come on in turn. And when it gets to the last LED lit, it will start flashing quite nicely. And that's at 1.3. And the first LED comes on about 0.2 or a volt. So yeah, that's a neat little bar graph display. My LED is not quite lined up in order, but that's understandable. For the breadboard, they don't quite fit on very well. Alright, well let's make one more circuit. We'll cascade 2 of these LM3914s and get a 20 LED bar graph display working. Okay, what I've done here is added another LM3914 and an additional 10 LEDs, and I've hooked it up so that they're cascaded, so we now have a 20 LED display. I have used the circuit from Forrest Mims engineer's notebook. Basically this circuit here, but as it says on the bottom, the circuit is adapted from the National Semiconductors datasheet. And in which case that is this circuit here, so it's simply been redrawn and some slightly different resistor values, but essentially the same circuit. So now I have omitted there is a switch to switch it between bar and dot display, but I have omitted that, so I'm just going to, I've got it hooked up as a dot display, mainly just to be kind on the little power supply for this breadboard, because as you can imagine, with all 20 LEDs lit up, there'd be a substantial current draw. They're all roughly running at 10 milliamps each. So, let's just wind up the voltage and see what happens. It's pretty much 1 LED per 0.1 of a volt, up to 2.6 volts. Down to 0.2 volts, and 0.1 is off. So yes, that is pretty neat. 0.2 volts to 2.6 volts. So there you have it. There's a basic little couple examples of the LED display driver chip, the LM3914, and that's about all I'm going to show you on that today. So thanks for watching, and cheerio.